Solving a system of equations by graphing and substitution. Okay, so we're going into our systems unit, okay? And what I mean by systems is up until this point we have been working with one equation only on the graph or one linear inequality on the graph. Well, from now on, when we're talking about systems, okay, we're talking about two equations, okay? That's what makes it a system, okay? So when we're solving a system of equations, we're going to do it by graphing, substitution, and elimination. So this video discusses graphing and substitution first, okay? So as you can see here, on the graph, there are three possibilities, and it would really be to your benefit, to go ahead and draw all three of these graphs in your notes, okay? And what I want you to know is that graphing a system of linear inequations on the graph is exactly the same that you would do with just graphing one line or one equation on the graph, only instead of having one equation or one line on the graph, you're going to have two. So, for example, I know that this, the blue line here is y equals, okay, blank x plus blank, and then I'll do the red line, okay, this is just, I just decided to say this in the moment. Okay, but the equation of the blue line is it crosses the y-axis at a positive 2, and our slope is a positive 1. Obviously, this is a negative slope, but it crosses the y-axis at a negative 1/2. So our y-intercept is a negative 1/2, okay? And the slope is down 1/2. So here are the two equations that are graphed on this line. Okay, and here's what you need to know. Super simple, okay? You're going to be given a graph like this, and they're going to ask you to identify the two equations that are on this graph like I just did, or they're going to give you the reverse. They're going to give you this, and you're going to have to graph this on the graph. But just to keep it super simple, they're going to ask you how many solutions does this system have? Well, these two lines intersect at one point, okay? So everyone go ahead and put a dot and draw a little arrow and point to that dot, okay? That dot where the two lines cross each other, this point right here where the two lines intersect, that is the solution of this system of equations, okay? So, and this means one solution, okay? So the solution for this would be a -1, +1, because every point on the coordinate plane has an x and y value, okay? So what you need to know is that there are three options with graphing, substitution, or elimination. There's either one solution, infinitely many solutions, or no solution, okay? So with graphing, you can visually see that the system of equations has one solution when they cross each other, okay? So when the lines intersect like this system of equations has one solution. It looks like there's only one line in this graph, but it's actually the same line graphed twice, okay? So the equation of this line is, okay, it's at a +1 and it's a -1. So this is the equation of the line, okay? And so what you need to know is that when you see the same equation graphed twice, it's going to look like there's only one line graphed on the graph, but it's going to say y equals, -x plus 1, right? So if it's the same line graphed twice, which means that it has infinitely many solutions, and the reason for that is because they agree every step of the way. They agree every step of the way. It's the same line, so that's why this system has infinitely many solutions. And then here we have no solution, which makes complete sense. Here we have two parallel lines. And what do we know about parallel lines? They have the same slope and they never cross each other, okay? So parallel lines has no solution because they never cross each other. Just like in our first example here, these two lines cross each other, so they have one solution, and the solution here is exactly at the point where they cross. So the solution is -1, +1. But parallel lines will never have a solution because they have the same slope and they never cross. So when you're graphing a system of equations, okay, you're either going to get one solution where the two lines cross, infinitely many solutions because you'll be graphing the same exact equation, or you'll get no solution because they never cross because they're parallel lines. Those are the three options, okay? So now I'm going to go to an example for you. And because we already know how to graph lines on a graph, I'm not going to spend a lot of time with this, okay? But here we go. I'm just going to scroll this down. So it says, solve a system of equations by graphing, okay? So let me unfreeze it and see where we are. Yep, I'm going to need to make it a little bit smaller, okay? Solve a system of equations by graphing. Let me scroll it down so you can see it. And basically, okay, now I'll make it a little bit bigger so you can see it in the video, okay? Well, there's the title right there, Solving a System of Equations by Graphing. But here we go. So I'm sure you guys are familiar with seeing two equations of a line, okay? Like with a little squiggly like this, little bracket, okay, that identifies that we have two equations that we're dealing with, which is your hint that it is a system, okay? And put a star in one, put a star, okay? Huge importance, muy importante, okay? You have to write this down. You must make sure, okay, make sure, exclamation mark, okay, that both, that they are solved for y. Make sure the equations are solved because, for y, exclamation mark. Solved for y. So I don't have an example, but you will get some examples in your classwork assignment today where both of these equations will not be solved for y. Well, you'll have to solve for y first to either be able to identify the lines on the graph, or you'll have to solve for y first so that you can do the graphing, okay? So huge importance here, folks, okay? So we have to make sure that both equations in the system are solved for y first. Very important. Then you graph it on the coordinate plane. How do we do that? 2 steps, right? Step 1, plot the y-intercept. And step 2, rise over run. We already know this because we did this in Unit 3. Only instead of doing it for one equation, we're doing it for both equations on the same graph, okay? So here we have y equals x plus 2, right? So we're going to go to a positive 2. Here it is. Plot the positive 2, okay? And then our slope is, even though it's not there, you know there's a 1 over 1 there, right? So we go up 1 over 1, up 1 over 1, up 1 over 1, and connect the dots. And here we have the red line. We just graphed the red line, okay? Now we're done graphing the red line. All right, now let's graph the blue line, okay? So we have to plot the y-intercept, which is at a -2. Here we are, plot the y-intercept. This is also a positive slope. So this is 3 over 1. So we're going to go up 3 over 1, up 3 over 1 from this point. So we're going to go up 2, 3 over 1, up 2, 3 over 1, put the dot, connect the dots, and you have just drawn the blue line. When you are done graphing both lines on the graph, you have to ask yourself, what do you see? What is the solution of this system of equations? Well, they both cross each other, intersect at one point. So this is one solution, okay? Easy peasy, okay? One solution. If the two lines cross each other, you have one solution. If they're exactly the same line, you have infinitely many solutions. If they're parallel lines and they never cross each other, then you have no solution, okay? But here we have one solution because they do cross each other, okay? So that is graphing a system of equations. I don't know, I've already like pre-prepared this, so I'm going to see if I have an opportunity for you to graph it first. Nope. So we're just going to go right on to substitution. Okay. So here we are. Great, great, great example. Okay. Oops. Keeps moving. Trying to get it centered. There we are. Okay, and then I'll just put this above it because that's going to be your practice. Okay, so here we are. Let me try to make it a little bit bigger. All right, so solving a system of equations using substitution, okay? So you should have written substitution and you should have already written, okay, this system of equations, okay? Here's the thing, folks. Super simple. Step one, make sure one of these equations, okay, is solved for a variable. Very important. Okay? One of these equations has to be solved for a variable. Very, very important. Okay? Then step two, substitute. Oops. Substitute and solve. Okay? What you need to know is that you are solving for, you are solving for that point on the graph where the two lines intersect. You're solving for where they cross, okay? So that point on the coordinate plane has an x and a y value. All right, so let's take a look at what we have here. We have y equals 3x, and we have x plus y equals negative 32. Well, step one was make sure one of these equations is solved for a variable. Is one of these equations solved for a variable? Yes. We have the top equation is solved for y. That makes our job so much easier. So what we're going to do is substitute and solve. So very, very simple. And I would like you to do exactly what I'm doing on the board in your notes, okay? Since the first equation is solved for y, you are going to circle, okay, what y is equal to. Let's do it together. Okay? Circle what y is equal to. This is how we substitute. Okay? And we point it to the y in the other equation. Why are we doing that? Because we are visually telling ourselves, okay, that this is what we're substituting in for the y in the second equation. Okay? Then we rewrite this second equation, substituting what y is equal to in for that y. So we're going to rewrite this equation now. Let's rewrite it. X plus, what is this y equal to? 3x equals negative 32. So here we are. So obviously, what variable are we solving for first? The x or the y? The x. So all we need to do is what? Combine like terms. We have 4x equals 4x equals negative 32, right? And the only step we have to do is divide by 4 on both sides, and x equals negative 8. Okay? Are we done? No. Okay? We know that our x is equal to negative 8. Okay? But we don't know what the y is equal to yet. Okay? So now we've done all the necessary work, but now we have to solve for y. Okay? How do we solve for y? Well, let's look at our original two equations here. Let's look at the originals, right? Up here I can see that y is equal to whatever 3 times x is. And we already solved for x. We know that x is negative 8, right? So you take what x is equal to, circle it, everyone circle it, do it now, circle it, and draw the arrow, point it, shazam, point it to the x, okay? And now you substitute this negative 8 in for this x here because y is equal to whatever the result of this is. Okay? So we're going to write 3 times negative 8. And our 3 Our positive times a negative gives us a negative, and 3 times 8 is negative 24, and this is our solution. Negative 8, negative 24. This point right here is the solution to this system of equations, and we did it by substitution. Now, what I cannot stress enough, you guys, okay? I said, what was the first step? You have to make sure, okay, that one of these equations is solved for what? A variable. I don't care if it's solved for x or y. Who cares? Who cares? Okay? One of those equations needs to be solved for a variable. Okay? So, why? Because it makes it easy to substitute. Okay. So, I'm going to put the next example on the board. Let me clean some shenanigans up here. And I'm going to put it on the board. And I'm going to stop the video so that you can have some time to try it yourself. And then we'll go over it together, okay? So hold on. Here is the example I would like you to try. There it is. Let me move it over. Okay, here it is. Let me make it a little bit bigger. Okay, here it is. All right, and I want you to go ahead and do that, and we will do that together. Yep, and that is, whoops, I forgot to freeze it. That's our only example for substitution. So let's go over this together, and then I'm done with our first video. This is our last example. So step 1 is to make sure that one of these equations is solved for a variable. Well, this is an awesome example because neither one of these equations is solved for a variable. So that means that I need to, try to simplify some things here, okay? So my eyes, just to show you a little bit of a trick, if you can see that the coefficients in an equation are all multiples of something, you can easily simplify that equation by dividing each coefficient by the common multiple that they possess. So all 3 of these terms is divisible by 2. So 2 divided by 2 is 1, 4 divided by 2 is 2y, and 18 divided by 2 is 9. So I can basically, I just want you to know that this equation means exactly the same thing as this equation above, only it's simplified, but it means it's exactly the same line, only I made it smaller with smaller numbers and easier to work with, okay? But this is still not solved for a variable. And so I'm like, okay, I'm taking a look at that. And then I thought, oh, look at the top equation. If I subtracted 3y from both sides, right? These would cancel, and then 4 minus 3 is 1. 1 what? 1y. Let me just write it here, okay? And we have y plus 3 equals x, okay? And then what would, it's already solved for x, okay? But some people kind of get weirded out by it because the x is on the right side. So if I actually took that and did this, x equals y plus 3, it means the same thing, right? And then I can write this, x plus 2y equals 9. So now we have a new system of equations. And guess what? This first equation is solved for a variable, which is what we wanted. So how do we perform substitution now, you guys? Okay? I just want you to acknowledge the steps that we needed to take to get there. No big deal. But again, let's do substitution. We have to circle. Do it now. Circle it with me. Yes, even though it's corny, do it anyway. Okay? Circle what the x is equal to and what? Point it to the x in the other equation to show that this is where you're going to substitute it into. Okay? So now we rewrite the second equation, substituting what x is equal to in for this x. So let's do that. We're going to start with y plus 3 plus 2y equals 9. Now, obviously, what variable are we solving for first? We have to get our x and y value, right? And there's only y in this equation, so we're solving for y. combine like terms, and we have 3y plus 3 equals 9. Have we solved for y yet? No, we're going to subtract 3 and divide by 3. So when we subtract 3 from both sides, we get 3y equals 6, divide by 3 on both sides, and y equals 2. So I'm going to put 2 right up here, okay? So our y value is equal to 2, but we're not done because we have to also figure out what is our x value equal to. Well, if we look at our two equations up here, x is equal to whatever the result of y plus 3 is. Well, we know that y is equal to 2. So we're going to take that 2 and plug it in for the y there, okay? So let me erase that and plug that in, okay? So x is equal to 2 plus 3. What's 2 plus 3? 5. And you have just solved that system of equations. So you know that this system of equations has one solution. Okay, so that is graphing a system of linear inequalities by solving a system of linear inequalities by graphing and substitution. Our next lesson will be elimination and then solving a system of linear inequalities by graphing. Okay, so that's it for that video.